So welcome to the another video of data structures using Java. In this video, we will be solving the problem on sorting, that is alternate sorting. So let's try to understand what does exactly the question mean is. So we will be given one array and we need to rearrange the elements of array in this fashion. That first of all I need largest element, then I need smallest, then again largest, smallest, largest, smallest. So in this way I need to rearrange every single element present in my array. So I hope so you understood the meaning of my question. Now let's try to understand how we can try to solve this problem. Now one thing is for sure that I need largest element. Now if you try to keep the same array as possible, what will happen is it would be really difficult to identify where is the largest element present in my array and where is the smallest element present in my array. But one thing is for sure that once I sort my array, I know that the last element present in my array will always be largest, the first element present in my array will always be the smallest. Again, the second last element present in my array is again the second largest, and the second element present in my array is always the second smallest. So what we can do is we can simply sort the elements present in my array. So if I sort this, it would be 1, 2, 3, 4, 5, 6 and 7. Now see, it would be becomes really easy to check out where is my largest element, where is the smallest, where is the second largest, where is the second smallest, right? So I know that my first largest is present at last because anyhow I have sorted the array in increasing order. So what I will do is I will simply print the first largest, that is 7. So I printed this 7. I am done with largest. Now what I want, I need a smallest. Since the array is already sorted in increasing order, my smallest will be present at its first position. So I will simply print it 1. Now I am done with the smallest and I want the largest. So largest is 6. So I will simply print it 6. Now I want the smallest. I have 2. Now I want the largest. I have 5. Now again I have smallest. I have 3 and the remaining is 4. So in this way we need to rearrange the elements present in my array. So I hope so you got the approach how we can rearrange the elements present in my array. But the really question comes in, how can I place this 7 and then 1, then 6 and then 2, 5 and then 3. So let's try to understand how we can place the elements present in my array. So what we have given is, we have given an array as 1, 2, 3, 4, 5, 6 and 7. This array is mainly given in sorted format, right? That is in increasing order. So one thing is for sure, first of all I need largest and then I want smallest, again I want largest, again I want the smallest. So what basically I can do is I can keep a 2 pointer. Let's suppose this is called as the end pointer and this is called as the start pointer. Now first of all I need largest element. So the largest element is mainly present at end pointer, right? So simply I will print the element present at end pointer, that is ARR of end, right? And what I can do is, since I have already printed this element, I will take my pointer to its left. So simply I will decrease the end by -1. Now as I printed largest, I will looking for the smallest element. So simply the smallest element is present at start index. So simply I will print ARR of start. And since I have used this element, again I will take one position ahead of the start so that I can go ahead with the second smallest. Now I'm done with largest and smallest. I'm done with largest and smallest. Now what I'm looking for? Again I'm looking for the largest element. So where is my largest element present? Of course at end. So simply I will print element present at end index and I will take the end index to the left side by 1. And I need the smallest now. So smallest is present at start index. So start index I will simply print and I will take it one position ahead, right? Now I want again the largest. So I will simply print the element present at end index and I will take this end index position by 1. And now I want the smallest. So I will simply print the element present at last, that is start index, and I will simply take the position 1 ahead. Now see, both the pointers are pointing to the same elements. Now if I try to put again the end and then the start, what will happen is I will end up adding this 4 2 times, right? I will end up adding the 4 2 times. So what I can do is I can keep a condition that if my start is equal to n, I can simply print any one of them. Since I want this 4 exactly once. So I hope so you got the dry run of this program. Now let's try to write the pseudocode for this problem. So what I want is, I want the 2 pointer which is s initially pointing to the first element and n which is pointing to the last element. And before that what we need to do is we simply need to sort my array. So simply I will sort the array. And what I will do is I will keep on doing this till my start is less than or equal to end. But before adding element, what we decided is we will keep this condition to check, because if both the pointers are pointing to the same element, I want that element exactly once. I don't want this 4 2 times, right? I don't want it twice. I want exactly one time. So what I will write over here is that if my start is equal to n, I will simply print it exactly 1. So print ARR of start. You can print any one, either start or end. And once I'm done it, I can simply break it out, because anyhow I'm done with all the elements, right? You're pointing with the 4, that is only one element left. So once you have printed 4, I can simply come out of my loop. Otherwise what I can do is, first of all I can simply print the largest element, that is n, and then I want the smallest element that is present at start. And simply I will do end minus minus, and here I will do the start plus plus. So I will write in a bracket that this is nothing but the largest and this is nothing but the smallest. So this is the most easiest problem. Now what will be the total time complexity for this? So what basically we are doing is we are traversing the whole array from the first element till last element. So the total time complexity would be nothing but big O of n. So I hope so you understood the pseudocode of the problem. Now let's move on to the IDE and try to submit our problem. So this is the problem present in GFG platform. So what I did is, first of all I calculated the length of my array, and then as we discussed that we need to sort the array in increasing order. Now I have declared the array list because they wanted to return the array list of my answer. Now as we discussed, start is pointing to my first position, end is pointing to my last position, and they will keep on going until unless both are not less than or equal to. Now once the start and end is equal, as we discussed that we need to add that element exactly once. So I simply added the element present at start and I break out from the loop because there was only one element left with. Otherwise, first of all I added the largest element and then I added the smallest element. So this is for the largest and this is for the smallest. And finally I simply move my start pointer to ahead by one position and I moved my end pointer to the previous position by one, and simply I return the answer that is simply this is array list. So let's try to submit this problem. Yes, so we are able to pass all the test cases. So I hope so you understood this problem really well. Just in case if you are new to the channel, do subscribe the channel for more such informative videos.